그렇지. 김혜연 씨, 네, 오늘 파일을 어떻게 할까요? 새로 지금 미리 올려놓지. 미리 오픈하죠. 네? 미리 열어놓죠. 네. 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 그럼, Hi, welcome back. Start. Any question? Schedule? Any item? Question? No? Everything is clear. Then we can start. Today we will cover the ocean renewable energy first part. And next week there will be a midterm exam, and then there will be no class on Thursday. And then the other week I will be traveling on United States, so we will have a online class only for whole week, 2 times. Right. So this is the ocean renewable energy part. So I will cover the renewable energy source and wind part. Oh. So this one, the renewable energy, what is the renewable energy? There is a time scale. Usually we are talking about human time scale rather than millions of years. So renewable in terms of, say, after million years, many other things can be used, renewable. Okay. And wind energy, wind resource is a sun. All the energy is coming from sun, you say. And a big energy is coming to the Earth's surface. Wind is a byproduct of solar energy, produced by the heating, uneven heating. And 2% of the sun's energy reaching the Earth is converted into wind energy. That is more. Still, we are using a little bit portion, very small portion of the wind energy. So why wind is blowing? See the video. We have a many video today.
우리나라 상황이라면 이게 살릴 수 있는 환자를 보내는 게 굉장히 힘들어.
Why does the wind blow? Wind is all experienced at one time or another. And whether it's a welcome breeze on a hot day or a destructive gust during a storm, it all starts in the same way. Differences in air pressure. Air is a mixture of gases in Earth's atmosphere. The weight of these gases pushes down on Earth, creating air pressure. How does air pressure cause wind? Wind is caused by differences in air pressure, and temperature can affect these differences. Gases are made up of tiny particles called molecules. When gas molecules in our atmosphere are warmed by the sun, they do three things. The molecules move quickly, they spread out, and they rise up. As warm air rises up into the atmosphere, it isn't pushing down on Earth quite as much. This creates an area of low air pressure. When gas molecules are cold, they do the opposite. They slow down, move closer together, and sink. As cold air sinks down in the atmosphere, the weight of the air pushes down on Earth's surface a bit harder. This creates an area of high air pressure. The sun doesn't heat all of Earth equally, so there are high pressure areas and low pressure areas all over the planet. In general, air always flows from an area of high pressure to low pressure. So, cool air in high pressure areas will rush into the low pressure area created by rising warm air. This rushing air is called wind. Why is some wind a gentle breeze while other wind is a strong gust? The strength of the wind depends on the temperature and pressure difference between the warm and cool air. Wind is important because it moves more than just leaves and trees. It moves storms too. Meteorologists can study wind direction to help figure out where a storm is moving next. They can also use weather satellites, such as NOAA's GOES-R series, to track wind by the movement of clouds. This helps to forecast the path of big storms, such as hurricanes. Whether it's a major storm like a hurricane or a gentle breeze on a hot day, all winds form in the same way. And now you know why. Find out more about Earth's weather.
Very mature, simple. We already know before, but we remind this. Okay, this one shows the advantage of wind power. So you can see that cost per megawatt hour is lower for wind and solar panel. They are competing each other. There's a natural gas and geothermal and coal comparing to the others. Gas is two different positions when there is a fluctuation, and the nuclear and so much. And this one shows testing of wind blade of wind power system. Wind blade. This is a wind blade. So single wind blade. And advantage, the price is low as technology is going up, developing, so that cost is going down. Also, the size helps to lower down the cost. And lightweight, larger diameter, and passive load relief. It means a twist flap. Before then, when there is a high wind is coming, they want to rotate the blade to reduce the let's say the angle of attack, to reduce the angle of attack because of the high wind is coming. Otherwise, if you have a blunt area up front to the wind, then you can have a high loading of it. So in old days, they use electric motor to rotate the whole blade to make angle of attack lower. And nowadays, they use passive relief method so that as the blade is bending, they can be twisted to lower down the. So they say this is a bend twist coupled with twisted. So bending gives you a twist because it's flexible. So this is a new technology. All right, so this is a global energy potential. Coal is biggest, uranium for nuclear, oil and natural gas. Wind is big comparing to other renewable energies. And solar is much larger, the potential. So we can use them, some of them. And wind resources around Korean Peninsula. This is Korean Peninsula. And then the coloring. So you may see that ocean is better in wind quality. And then what else? This is a picture coming from Jeju Island. Jeju Island is located here. There's a wind power system there. And this one is a mountainside. Here it is, mountainside. There is you can see some red lines with the high mountains there. So there is a Daegwangyeong in Koreans know that there is some wind power system. This is a location of wind land fixed wind power system, total of 1.6 gigawatts. And how does wind turbines works? There is a blade, and wind is blowing, and then something is rotating there, and it gives the generator, making electricity, goes to the network for the transfer to the home. There is a gearbox inside to lower down or increase up the RPM to make a generator. So there is a inflow of wind that gives you inflow of wind, activate rotor and blade, and rotor and blade spin the main shaft and gearbox. Video. Right. We may better to see the video.
How does a wind turbine work? You've probably seen a wind farm. But do you know how wind force is converted into electrical energy? We are going to show you how a wind turbine works. Each wind turbine has a wind vane at the top that indicates the wind direction. This allows the turbine to rotate on the tower and face the wind. The blades also rotate on their axis for maximum resistance. Wind force, that is, the kinetic energy contained in moving air currents, spins the blades. These are designed to fully capture its energy. They can be as long as 60 meters each and are made of very light and resistant materials for ease of movement. This is why they can produce energy even with very light winds, starting from about 11 kilometers per hour. With very strong winds, above 90 kilometers per hour, the blades are placed in the feathered position and the turbine stops spinning for safety reasons. The blades are attached to the wind turbine through the hub, which is coupled to the low-speed shaft. The low-speed shaft is given this name because it spins at the same speed of the blades, between 7 and 12 revolutions per minute. To produce electricity, it is necessary to increase the turning speed of the low-speed shaft. That is the mission of the gearbox, which raises the speed over 100 times and transfers it to the high-speed shaft. The high-speed shaft, that rotates at up to 1500 revolutions per minute, is connected to a generator. The generator converts the kinetic energy into electricity, a source of energy that is easier to transport and use. The electricity produced in the generator is conducted through the interior of the tower to the base. There, the transformer raises the voltage for transport inside the wind farm. From each turbine, alternating current is sent to the substation through underground cables. Here, the voltage is increased again to feed it into the power grid and transported to end consumers. This is how we use the wind to light cities, feed industries, schools or hospitals, or operate our household appliances in a clean and
Okay. Question? No. And there is also horizontal axis and vertical axis. This is a typical one. We call this is a horizontal axis. This is a horizontal axis, so that the rotor is rotating around the axis. We call this a rotational axis is horizontal. But this one is vertical, so that the blade is rotating around the axis of vertical. This one is a smaller version. It can be a bigger one comparing to this one. So there is no need for wind tracking because all side, any direction or wind can rotate this one. There is advantage, and then also environmental concern, less environmental concern. But usually the efficiency is lower. But because of this wind track, the directional allowance, the coverage of wind direction can be a little bit bigger than this one. So it is something pros and cons. So we need to compare the whole picture. And also as the size is bigger, this portion can be heavier in terms of weight. But this one is better in that position that the heavy weight can be placed in the low position. That is another advantage. And then, there's another one. So the vertical axis.
농막에는 물이 없어요. 집이 없었기에 수도를 안 넣어줘요. 그럼 물이 귀하지.
What to choose? Vertical or horizontal axis turbines? When you imagine a wind turbine, you probably think about something like this. But there are other designs out there, like the vertical axis wind turbine, or VAT in short. The Savonius model is very crude and was already used by the Persians 3,500 years ago. Then there is the Darius model, with blades revolving around a vertical shaft. Each blade gets hit by the wind at a different angle. They make use of an airfoil design, so they generate lift to make the turbine rotate. A generator at the bottom of the structure converts the kinetic energy into electricity. The VATs are omnidirectional. They do not need a yaw mechanism to be pointed into the wind. Also, compared to horizontal turbines, VATs can be grouped closer together, because they can operate in a turbulent and gusty wind. So why don't we see more VATs then? Well, VATs tend to be less reliable and less efficient than horizontal turbines. This makes them less suited for large-scale energy production. But the field is still under development, so who knows? We hope you enjoyed this short lecture. Would you like to know more about offshore energy? Click here to see more of our videos.
Okay. And evolution of blade size, we already covered several times. Here is Washington Monument, and also Liberty, and cruise ship, comparison, and this one, this is energy size. So for a nuclear power plant, we call Gori is in Korea, and capacity is about gigawatt, increasing also too as numbers go high. You see the construction year in 70s and 80s. And then if you replace wind turbine to nuclear, you need to have 100 of them. So let's cover this one. Okay, let's see. Question? No question. Even though I saw the 3 video here, very quick, and we can have a 5-minute break. I will come back 25. Maybe. Blue can be the next speaker.
새 시대
Wave energy is
this massive tidal
Hey, across of the building.
Okay, so I'm going to present you the second part of Ocean renewable energy. So the first part was introduced by the professor of wind energy, and me, I'm going to do tidal and wave energy. So what is tidal? So the tide is a periodic rising and falling of the water that results from the gravitational attraction of the moon and sun. And the solar tidal force is approximately 50% as large as the lunar. So as you can see, it's a periodic one, and it happens twice a day. So you probably seen it if you see the sea. So the characteristic of tidal energy. So there's a huge concentration of tidal energy, especially in the coastline. Of course, there's tidal energy is really effective and it's predictable. So it's an easy mix with other energy resources. So it's kind of a good way to use the waves. So there is two categories of tidal energy. The first one is tidal barrage, so dam, and its use of potential energy, so kinetic energy from the sea motion. And tidal stream capturing, so it uses also kinetic energy, and they use turbine, oscillation winds, and other concepts. So I'm going to show you a different concept that is used nowadays. Well, I don't know why it's supposed to have a picture here. Maybe, yeah, sorry. Anyway, so tidal barrage, so how it works. So as you can see, so there's the sea and the estuary, so two parts, and between it there is a barrage. So as you can see, when the tide come in, there is a difference of high water. So the sea is higher than the estuary. So the motion of the water is going to the estuary. in this little space, and this motion drives the turbine, and it leads to electrical energy. And when the tide goes out, it's the same way, but at the opposite direction. So I can show you a little video that explains it.
Okay. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity, and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
Okay. Okay, so I'm going to present you one of the tidal power, which is in France, so in Saint-Malo. So you have the location of Saint-Malo just there. And so it's the oldest tidal power plant. So the start of the construction was in 1961, and it took 6 years to complete the whole construction. So it has 24 turbines, each rated at 10 megawatts, so the power is 240 megawatt, which is a lot, but nowadays it's not the most powerful. The most powerful is one in South Korea, actually. And the installation cost was about 800 million. And actually, it say in the video that it's quite environmental friendly. It is, but for Saint-Malo, there was kind of a siltation issue because of this tidal. So they have to face this issue, but nowadays it's fine. They use new techniques. So the comparison of tidal power, so there is one in France, Florence, and the most powerful is Cyprus in South Korea. And I think there's, yeah. So it opened in 2011. The steam generator at 25.4 megawatt. And there was supposed to be another one in South Korea, but it was canceled due to environmental and ecological issue. And as you can see here, construction cost was 300 million, so it costs a lot, and it has to be really efficient. So this is why there is not that much tidal power plant in the world, because you need to choose the right location so that can be efficient enough compared to the construction cost. So now I'm going to talk to you about wave energy. So I'm just going to introduce you some techniques that are used nowadays. So the first one is Polaris project. So it's like a snake shape. that you can see that you put on the water. And so it used the kinematic motion of the wave. And as you can see, so it goes up and goes down. And this motion puts it hydraulic ones in action that can drop the engine and produce the electricity. And the electricity is carried by subsea cable, like you can see here. So I'm going to show you a little video after. Just going to continue to introduce you to some techniques. So there is the ball wave energy converter. So as you can see, it contains a pump that rises and falls with the wave. And this pump pumps seawater, which turns the turbine to generate electricity. And as the other one, the electricity is transmitted to shore through underwater. Here is the wave energy converter. So this one is quite huge. So this engine actually here goes up and down. And when it goes down, it compresses the water. So there is water through this flow line to high pressure, and then it can convert with hydroelectric power, can convert it to electricity. Another one is uncoiled buoy. So it's another concept based on vertical motion, and it's generated by relative motion of the attachment inside the boat. So it's fixed to the boat, you can see here. And this one is called wave dragon, so it's overtopping wave. So as you can see on the picture, actually the wave goes on the engine. So the water is on the reservoir and then it can go down in the turbine. So it's kind of the water drive the turbine and generate electricity. So I'm gonna show you a little video.
Is created by the movement of the ocean's surface. When a wave energy is created by the movement of the ocean's surface. When a wave rocks a boat back and forth, it's doing work. That energy can be captured and used to generate electrical power. If harnessed properly, it has the potential to provide 10% of the world's energy needs. The three most common methods to harness wave energy are attenuators, overtopping systems, and point absorbers. The attenuator rig sits upon the ocean's surface, giving it a snake-like appearance. Each section is connected by a joint that allows the attenuator to undulate along each wave. The movement of the wave pushes and pulls hydraulic cylinders, causing fluids to compress into high-pressure accumulators, creating an electrical current. The attenuator was the first wave-powered generator implemented for commercial use and has the capability of powering up to 500 homes per unit. In March 2003, a European team in Denmark launched a floating 237-ton prototype utilizing an overtopping system. The overtopping works like this. When a wave approaches the rig, two wave reflectors guide the water to the center and up a curved ramp into the reservoir where the water is stored. From there, it's run through several hydro turbines. The water pressure spins the turbines, and the energy is converted into electricity with a magnetic generator. Overtopping rigs can withstand environmental hazards fairly well. The rig was designed to be large and heavy to combat any rolling and pitching. The low floating and heavy design allows giant winds and waves to simply pass over the rig. Another way to collect wave energy is using a point absorber. A point absorber works using a buoy that floats above the water to generate power. A giant shaft is anchored to the seafloor with the buoy secured on top. As the buoy moves up and down with the waves, the pumping action is converted into electricity. A single unit can generate enough power for 40 homes. The next generation is predicted to generate 4 times that amount. Put them together in a farm and a power plant is born. With further research and development, wave energy just might become a major contributor to the team of renewable energy all-stars.
So one of the last concept is a air turbine. So as you can see in the pictures, I'm going to explain you when the sea goes in the left direction down, and the air can enter this structure, and when the wave comes, So the waters goes on the structures, in the structure, and so the air is it's kind of there is kind of a pressure that is applied by the water. So the airflow can drive the turbine and then generate electricity. And I did some research about other projects. So these two are quite recent. This one is now applied, but this one is still in development. And I can show you 2 videos about it. So it's really a recent research. So the first one is this one, which is WebTOS wave energy.
The WebTOS wave energy converter delivers a stunning performance. With a high efficiency and optimized use of construction materials, WebTOS produces energy at a very low cost, making it a competitive contribution to global energy supply. Key to the technology is the design of a self-buoyant rotor, which transforms wave energy into rotating motion. The movement is controlled solely by the balance from ballast, which is more than half of the total weight of the rotor. Offering peak efficiency at almost 100%, the rotor delivers energy through a simple and reliable drive system that ensures energy from any movement of the rotor. This energy is transformed through one-way rotation of a common axle. The rotors combined create a smooth and constant delivery of energy to the power generator. With a speed in the same range as that of wind turbines, WebTOS is able to use exactly the same generator technology. The floating wave energy converter is positioned by a strong mooring system, which can be easily installed at almost any depth. As the mooring is particularly designed to be flexible and allow full rotation, it secures a maximum production no matter the direction of the waves. Depending on the weather conditions, there is a great variation of energy from waves. WebTOS deals with this by changing the angle and the corresponding width of the wave energy converter. Therefore, the power to the generator is optimized to a much broader range of wave conditions, allowing a larger benefit to its annual energy production. The closing of angle in the system has also proven its superior effect in extreme weather conditions by minimizing forces on the structure. Without the need for extra strength to survive storms, costs are kept as low as possible. Access to WebTOS is safe through the calm area behind the wave energy converter.
I'm going to stop right here and just show you the second one. So I'm not going to put all the whole video because it's quite long, and just to explain you how it works.
In 2016, a few young engineers competed to make the most efficient wave energy device to create clean, renewable energy from ocean waves. Beating 90 other teams, their technology took second, but that's just the start of this team's story. With their winnings from the US Department of Energy's Wave Energy Prize, the team gave themselves a name, CalWave, and kept working. Eventually, they invented a new kind of wave energy architecture, dubbed X-Wave, the bones to build smaller or larger machines to generate varying amounts of energy. Now, with help from DOE's Water Power Technologies Office, CalWave is taking their X-Wave architecture to the ocean. As of September 2021, CalWave achieved their first X-Wave deployment, calling it the X1. Deployed off the coast of San Diego, it's also California's first open-ocean, long-duration wave energy pilot project.
So the device is really revolutionary in a couple of aspects. The first of which is that it's operating fully submerged underneath the water surface. And that really allows the device to absorb energy from multiple degrees of freedom. So it does not only absorb energy from the up and down motion of the device, but also from the left and right, and also from the rotational degrees of freedom.
CalWave's device converts wave energy into electricity. During its 6-month test at the Scripps Institution of Oceanography's research pier, the company will collect data on how well their technology performs at sea. While wave energy technologies are still young, architecture like X-Wave could soon help power the blue economy, including offshore work like marine research, fishing, and military missions, or even supply whole towns with clean energy from ocean waves.
So as you can see, it's still in development. I mean, it was in 2021, but it's still in development. So here, and the last one is also a video. It's quite long. I don't think we have time to see it, but it's one of the most powerful tidal turbine. So that's it. Thank you.
Yes. Sure. Now, can continue on discussion session.
Good afternoon, everyone. I am Hanshim, and I will be present for today's discussion section. The first discussion topic is ocean renewable energy. Specifically, we focusing on 3 renewable energy sources that we covered in today's class. There are 3 renewable energies. Can you connect the correct name above the picture?
On the right is it's wave, the middle tidal, finally on the left is
Yes, right. The first one is wind energy, and second one is tidal energy, and third one is wave energy. And what is the operation method of each of renewable energy sources? Of course, the wind energy is operated by wind, and explain some where wind comes from. Can you explain?
and the first one for wind. Yes, it's converted by wind and basically the difference of pressure in the atmosphere.
Yes. It comes from, the wind comes from the different atmosphere temperature. And how about tidal?
Tidal is the change of height in water level current due to the process of the sun.
Yes. And how about wave energies?
Simply the movement of water in water.
Yes. This lunar water surface. Right. So wind power is produced by wind caused by uneven heating of surface of Earth, and tidal energy is produced by natural tide caused by gravitational interaction between Earth, Sun, and Moon. And then wave energy power produced by the up and down motion of floating devices produced on surface of the ocean. And what do you think the best? What do you think is the best method? Do you have any opinions?
I think the best one is tidal because it's highly predictable. It's highly predictable.
It also depends on where you put it. Like you cannot use tidal everywhere. It's probably not the most everywhere, but if you can use it already.
But you may not.
So I'd say depending on location, everywhere could be best.
I think that's all right. Then let's talk about pros and cons of each of renewable energy sources. Firstly, what is pros of wind energy?
First of all, there's three kinds of energy that are renewable energy, so it's eco-friendly.
Yes, eco-friendly. For all of renewable energy sources. And any other?
It's also the cheapest.
Yes, it is cheapest.
Tidal is predictable.
Yes, it is predictable. Then how about cons of each source?
The way it really depends on the season or the time of the day, so it's not predictable.
Yes. A wave or wind?
Or wind.
Wind. Any other opinion?
Maybe the tidal production does not follow the human production of energy.
For
like as Glenn said, the tidal energy doesn't produce energy always at the right moment and the right power plant.
Okay, and not predictable and for other opinions.
It's expensive.
Expensive for tidal?
Yeah, like subscription.
Yeah.
Maybe for waves with many things on the ocean to make disrupt the ocean life.
I think it's enough. This is my answer. So for wind energies, it is relatively cost effective than other things, and it can produce more power. However, it has variable generation since wind is highly affected the weather, and it requires large space. And for tidal energy, it is predictable and easy combined with other resources. However, it has challenging integration and maintenance. And also, it can impact the ecosystem. And for wave, it is renewable energy source since waves are hardly interrupted and always in motion. However, same as tidal, it has challenging integration and maintenance, and it can impact the marine system. And the current discussion topic is offshore wind farm. Recently, offshore wind farms are increasing in addition to land-based wind farm. There are several types of turbine system depending on supporting structure. First one is monopile foundation consisting of single steel tubes that are driven into seabed. Second one is jacket foundation using a lattice framework and usually have 3 or 4 anchors set on seabed. Third, the last one is for floater equipped positioned by mooring lines with driver traction anchors. Can you guess what it is? For last 3 of them.
So for deep water on the right, it's spark water. Traditional water is for a jacket. It's finally pipe or ocean.
Yes. Right. It is the answer. You're right. So these kind of structures allowed wind turbines to be installed in the deep sea. Now we compare the onshore wind farm and offshore wind farm. Can you anyone fill this blank? It has just 2 choices open for each of category.
So for the specific power, 340 watts by square meter is for offshore, and Midwest is for offshore. For the water diameter, it's the same. So equal is offshore.
Offshore. And same?
Yeah.
Yeah. Wind speed is also right. The answer. Can you explain the relation between the specific power and the other variables?
Yes, so the specific power that you can extract from the wind is depending on the wind speed and the quantity of wind that you can use with your oil. So when you have a higher water diameter and a higher height, you will be able to capture more wind. And if it has a higher speed, you will be able to capture more power.
That's right. As rotor diameter and hub height and wind speed is increased, then the specific power will increase. And let's talk about pros and cons of offshore wind farm compared to onshore wind farm.
Like we just saw, there's more power generation because the wind speed is higher.
Yes, it's more place in the space that you see.
Yes, more place. Because there are, we don't need to consider the people's society. And then
in cons, maybe how do you bring the power back to land?
Effect of wind. Effect.
How the power you generate, you need to bring it to
land. It is hard to deliver the wind power to land.
Another one is maybe stability problems.
Stability.
It's harder to fix if an issue occurs on a shore with farm. So,
so the ships now have to drive around.
Ship. One more time.
I don't know. The ship routes are disrupted.
Ship route is. What?
it's more expensive to create an issue with farm than shore.
Expensive. Any other pros?
Nobody lives in the ocean, so it won't annoy people.
Not only people.
Nobody will complain about the noise of turbines. That's a pro.
Your opinion? Yes, I think it's enough. There are some pros and cons. I think for pros, it can generate more power and more steadier with also steadier supply of wind than onshore wind farm, and not affecting people's society or bad appearance or noise. But it is more expensive than onshore wind farm and challenging with installation and maintenance. And it can be less local involvement, like more jobs or yes. That's all. This is my references, and thank you for your attention.
All right, that's it for today. No question? The next time you'll see. But the exam will be here, isn't it? All right.